Okay then, well, good afternoon everybody, and welcome to today's session, Database Adventure. As you can probably guess, this session is in English, so I fully understand if it's not everybody's cup of tea. First things first, a big thanks to all the organisers, volunteers and sponsors, without whom today's event would not be possible. Obviously, working on these events is not an easy task, I can tell you that from personal experience. Now, a bit about myself before we get started. My name is Chant. I'm a senior database architect for Society over in the Netherlands. However, as some of you can probably pick up from the accent, I'm actually originally from the southwest of England. However, I live in the Netherlands due to the fact my wife is Dutch. So basically, I'm an Englishman living in the Netherlands, working for a French-based company because he met a woman in Australia. As you can imagine, this gets a bit confusing for some people, and administration can be a bit of a nightmare sometimes. Now I have over 22 years experience working in IT, and over that time I've worked in various sectors, including the banking, oil and the health insurance industries. In fact, I've supported companies in the top 10 of the Fortune 500 list over the years. In addition to that, I've worked with all versions of SQL Server in one form or another, as well as other database management systems. And I have various certifications, including both the old and the new style MCSE, and I was probably the last ever person in the world to gain the MCSD Azure Architect certification before it was officially retired by Microsoft. Now, as you can see below, I'm on Twitter at KevChant. I'm also on LinkedIn on a nice, easy to use URL. I have my own blog as well, which I post a lot about stuff, and recently I've been posting a lot to do with SQL Server 2019, as well as Azure related technologies. And my email address is available upon request. Now, a bit about this session, because it might be a little bit different for some of you. It's an audience interactive session, where you'll be asked to make a decision in certain situations. Now, to make things easier for yourselves, I've put letters next to all the different options that you can choose. So all you have to do, if you want to choose an option, is just put your hand up and tell me which letter, and I'll confirm the choice with you. Now, there will be times when there's only two options to choose from. When that happens, I'll say what the options are, and then I'll ask you all very nicely to put your hands up to vote on one or the other, if that's okay. Now, this is based on a role-play scenario where you're a new employee for a large Polish corporation. And various topics will be covered depending on what is chosen by yourselves. So you could be dealing with virtualization, or indexes, or SQL-related technologies in Azure, or even Azure Stack. And just a quick note as well, recently I've been doing a lot of work with SQL Server 2019, so I have added some new content to this session, so it's worth keeping an eye out for. And for full disclosure, all the images you see today are from either openclipart.org or the Microsoft Cloud and Symbol set. So, now that's out of the way, let's go. Every tale has to have a beginning. And it's your first week in a new job. And your new boss tells you there are potentially two things you can cover at the moment. One is a SQL Server 2012 performance issue on an instance that hosts very large databases. The other is SQL Server 2019 consultancy, because your new employer is part of the early adopter program with Microsoft. So, which one do you want to deal with? And as you can see, everybody, there's only two options here, so I'll go through them both, and then I'll ask you to auto-vote in a minute. So, do you want to deal with A, SQL Server 2012 performance issue on very large databases, or do you want to deal with B, SQL Server 2019 consultancy? So, put your hands up if you want to deal with A, and put your hands up if you want to deal with B. B just ever so slightly wins there, and only just, it is a narrow margin. Now, most of the time everybody goes for A, but obviously this is new material. And you're actually the first ever people to see this new material, by the way. So, Your boss has asked if you can help with SQL Server 2019 consultancy for various teams. And he asks you which one you want to deal with first. So which one do you decide you want to deal with? Do you want to deal with A, a SQL Server 2012 compatibility level query from the accounts department? Or do you want to deal with B, a SQL Server, upgrading SQL Server 2019 CTP 3.1 query from your marketing team? Or do you want to deal with C, an always encrypted query from the sales team? Now, who wants to make the first solo choice in today's session? Just put your hands up if you do. So you're all going for A. SQL Server 2012 Compact Level Query from Accounts. So, you read a request from the Accounts Department who inform you they need to keep a database in SQL Server 2012 Compatibility Level in SQL Server 2019. Now, you will get these requests now and again for various reasons. A lot of the time it's due to application support from the vendor, and sometimes it will actually be due to the fact that the vendor doesn't exist anymore, but the department are willing to take the risk. Anyway, back to the tell. And they tell you they still want to use clustered column store indexes if possible on this database, even though it's using SQL Server 2012 compatibility level. So, which index do you actually decide to try and build for them? Do you go for A, a non-clustered column store index? Or B, clustered column store indexes on tables with certain LOB columns like varchar max and var binary max? Or C, clustered column store indexes only on tables without any LOB columns? Now, who wants to make a choice here? Anybody? I'll wait a minute for it to see. B. So you're saying clustered column store indexes on tables with certain LOB columns. It's a very interesting choice to make. And it's actually a good one as well. So you create a clustered column store indexes on order tables, even those that have columns with certain LOB types like varchar max. And you test the updates and the maintenance, and it actually all works just fine. So afterwards, you demonstrate this to the accounts team, who are very impressed. Now, I have done a diagram that shows something quite interesting here, because there is a bit of a misconception for some people that if you have a database at an earlier compatibility level, you're restricted to what indexes you can create. However, as this chart clearly shows, which indexes you can build on a database depends on the SQL version and not the database compatibility level. Now, does that make sense to everybody? So, for example, if you have a database in SQL Server 2019 and it's in 2012 compatibility level, you can still build clustered column store indexes on there. So, afterwards, the team asks if you can test using the new database scope configuration setting for online index rebuilds. Now, for those of you who don't know what I mean by that, in SQL Server 2019 and in Azure SQL database, they've recently introduced a new database setting which allows you to have online index rebuilds as a default. And what I mean by that is, if you use an auto index rebuild statement, but you don't put in the online equals on at the end, SQL Server will still try and do an online index rebuild. It's quite a useful feature, especially if you're dealing with very large indexes and you want to work on them during the day. So, back to the tell. And because you want to make sure that the column store indexes are rebuilt online, what do you decide to do? And as you can see, everybody, there's two options here, so I'm going to ask you all to vote again in a minute. So do you A, test with the SQL Server 2012 compatibility level? Or do you B, request that the team upgrade to SQL Server 2019 compatibility level first? So, put your hands up for A. And put your hands up for B. Well, let's see what happens. So you tell them there's no point because it only works with SQL Server 2019 compatibility level. Afterwards, one of the team actually contacts you to say they've tested it themselves. And it actually works if you use the fail unsupported option. So it's a very interesting workaround in SQL Server 2019 that you can do. And one that in theory should not even work. With this new setting in SQL Server 2019 and Azure SQL Database, you have three choices. Either don't have online index rebuilds as default, or have it set to when supported, or have it set to fail unsupported. However, I have tested this, and it seems that if you use fail supported, it forces it to actually work. So if you have a database with SQL Server 2012 compatibility level, not only can you build cluster column store indexes on there, but you can force SQL Server to set online index rebuilds as a default for them. Got a bit tongue tied there. Now, does that make sense to everybody? But it only works if you use fail unsupported, and I do recommend you test it yourself as well. So, the team will explain that they currently import an Oracle database every week in the SQL Server, and the process takes around about a day. After they import the database, the data is manipulated, and then it's exported elsewhere. So, what do you suggest they look at for SQL Server 2019? Do you suggest A, they look into Polybase, or B, they look into big data clusters, or C, that they do some more research? Now, who wants to make a choice here? A? Okay, well, before we go to look at Polybase, I'll just quickly cover about big data clusters as well. For those who aren't aware, big data clusters is something that's new in SQL Server 2019. Effectively, Microsoft have incorporated a big data solution into SQL Server now. However, it's not installed in SQL Server 2019 by default because it's quite involved. And in fact, if you want to use big data clusters, you need to use somewhere that hosts a Kubernetes service. Because like other big data solutions, it needs multiple machines. In addition to that, big data clusters natively supports HDFS. Now, has anybody got any experience with Hadoop? It's basically the same file system that's used with Hadoop. And in addition to that, it natively supports Spark and Spark ML jobs. So it's all ready to process large amounts of data effectively. So anyway, back to the tell, and let's cover Polybase. So, you suggest to the team that you can use Polybase instead, because then they can data virtualize the data within their database. And it's an easy method to implement if you want to perform data virtualization. And what I mean by data virtualization is essentially you create what I like to call a virtual table within your SQL Server database. And you can query this table just like any other table, except this table is actually just a pointer to the data that's hosted in another database system. Now, it was first implemented in SQL Server 2016 and had a few issues and had limited capability. However, in SQL Server 2019, they have improved it quite significantly. And now it can be used to query against a lot more data sources, including Oracle and SAP HANA related systems. So, and also you can actually use Polybase in conjunction with big data clusters as well. So as you can imagine, it can be quite powerful. Anyway, back to the tell. And you add Polybase for them and they test it. And after some issues, they're able to get it to work fine. So in fact, in this situation, it's quite useful because obviously you could have used big data clusters, but it may have been more involved than it needed to be for that problem here. So, after all of that, your boss calls you and asks if you can look into a SQL Server 2016 issue. So, Like I said, you're asked to look into a SQL Server 2016 instance problem on an instance that hosts very large databases. So you get your favorite script that shows what SQL Server is currently working on at the moment and the percentage complete. And you notice that CheckDB appears to be running against a large database at the moment, even though it's in the middle of the working day. So what do you decide to do? Now, as you can see, everybody, there's only two options here, so I'll ask you all to play together in a minute. So the options are A, let it finish, or B, stop the job. So, put your hands up if you vote for A, and put your hands up if you vote for B. It's a close call, but again, B just narrowly grabs it there. Don't worry, this is an interesting one for you all. So you stop the job and you monitor SQL Server to see if it's been finished. However, when you go to check it's been finished, you see it's still running, and the rate type for it is xxsync. So you do what most of us would do, and you execute the kill command again quite a few times. And then you run your favorite script again, and you see it's still there, and the rate type is still xxsync, and it looks like it's a zombie SPID. So you explain to your colleagues what's going on, and they ask you how you can fix this. So, what do you tell them? Do you say A, restart the SQL service? Or do you say B, restart the server running SQL? Or do you say C, just keep executing the kill command? Now, who wants to make a choice here? A. That is the most sensible choice, to be honest. I'll just quickly cover right now. If you'd gone for B, obviously it's a bit of an overkill. And not only that, if you've just inherited a new SQL Server environment and you restart this server, you may get a nice surprise that it's actually a physical machine and not a virtual one. And it would take a lot longer for the reboot. And then at that moment in time, you might also discover that they haven't implemented Always On this server. So your databases are completely unavailable whilst the reboot's taking place. So as you can imagine, you could have been in quite an interesting situation there. Anyway, back to restarting the SQL service, which is the most easiest solution to do. So you tell your colleagues to restart the service, knowing it will clear the SPID. And once it's restarted, the SPID is gone, and everybody breathes a sigh of relief and goes home. However, the next day you walk into the office to be told there are reports of slowness on the very same server you fixed the day before. So, you ask your colleague what's going on, and they explain to you that once upon a time, Microsoft asked them to run SPMS for each DB and SPMS for each table together, with an update statistics with full scan statement wrapped in between them. And for those of you who aren't aware, what this basically means is that SQL Server is going to update all of the statistics, in all of the tables, in all of the databases, using the full scan sample rate. And as you can imagine, on a system that's got very large databases, this is going to take some time to do. And based upon this previous experience with Microsoft, your colleague has taken it upon themselves to run this again now. So what do you decide to do? And as you can see, everybody, there's two options here. Option A is to tell them to carry on, and option B is to ask them very nicely to stop updating the statistics. So, put your hands up if you vote for A, and put your hands up if you vote for B. I think it's quite unanimous there. So, you asked your colleague to stop updating the statistics, and they suggested to you if you should check this with your boss, because there's a level of paranoia about the server after yesterday's issues. And your boss asked you if it's okay to cancel updating these statistics whilst they're running. So what do you say to them? And as you can see, everybody, there's two options again here, which are A, yes, it's fine to cancel, or B, no, you have to wait until you finish to prevent a rollback. So, again, put your hands up for A, and put your hands up for B. Somebody's been devil's advocate there. So, you tell your boss to find the council updating the statistics whilst it's running, as there's no or little chance of a rollback. So your colleague cancels the script and everything goes back to normal. And your boss is impressed with your knowledge and is of course very grateful that he's not getting any phone calls. And they tell you they've purchased a Visual Studio subscription for you so you can configure your own test lab. So, like I said, your company's purchased a Visual Studio subscription for you so you can create your own test lab to test new environments. And what I mean by that is multiple versions of multiple SQL Server instances to test things like high availability on. However, first of all, before you look to do that, you decide you want to test building a big data cluster, since you were talking with the team about it earlier. So, where do you want to start when you go to look to deploy your first big data cluster? As you can see, everybody, there's two options here again, which are A, SQL Server documentation, or B, SQL Server Big Data Cluster Workshop. Now, put your hands up. Oh, by the way, before I do the folks, for those who aren't aware, SQL Server documentation is the latest name of SQL Server books online. It's been renamed. So, put your hands up if you vote for A, and put your hands up if you vote for B. Oh, B seems to be very popular this afternoon. Maybe next time round I'll swap them around for everybody. So, you decide to use the Big Data Cluster Workshop. And even though it's currently based on SQL Server 2019 CTP 3.2, it still works with the latest release candidate. Now, for those of you who aren't aware, SQL Server 29 release candidate 1.1 is currently available for download. Now, 1.1 might seem like a strange numbering convention to some of you that use release candidates over the years. And the only reason there's a 0.1 at the end at the moment is because Microsoft put it there for big data cluster support. Anyway, back to the tell. And you have a few issues setting it up initially, mostly due to the fact you try and change the settings from the defaults they have in the instructions, like you want to change the regions and the machines, etc., which don't actually exist. However, eventually you're able to create your own big data cluster which suits your needs. And in addition, you find the hands-on labs that come with it very useful. Now, I've gone through this workshop a couple of times now. I actually went through it first for to deploy a cluster at the start of the year when it was first introduced. And I also done it recently when it was updated for CTP 3.2. And I can vouch for the fact that deploying them using this version for CTP 3.2 is a hell of a lot easier. Plus it does, like it says there, it comes with some very useful hands-on labs. So if you want good hands-on experience with big data clusters, I recommend using the workshop. So, after you finish experimenting with big data clusters, you decide to go ahead and test creating your test environments. Now you're wondering where to test it because you want to use it whilst you are commuting to other places. Also, you want it as close to the traditional installation experience as possible because your new employer doesn't use containers yet. So where do you decide to build it? You decide to build it A, in Azure, or B, on your laptop using Docker, or C, on your laptop using Hyper-V. Now, who wants to make a choice here? You want to go for A? In Azure, yeah? Why not? So, you decide to build your test lab in Azure. And the good news is, as some of you know from the sound of it, that you get to use a lot more services. However, the downside is that sometimes whilst you're commuting, you lose your internet connection, so you're not able to use it there. So that's just something to bear in mind. Azure is really good to use, but you do need your internet connection. Or at least you have to be a bit smart when you're going to use it whilst you're traveling around. Otherwise, for example, you might end up creating a large virtual machine and then get on a train and lose your signal. And you find when you get to your destination that you've run out quite a high bill. So anyway, you decide you want to get your test lab environment up and running with multiple machines created in Azure using an IaaS solution. So how do you decide to do this? Do you decide to use A, PowerShell, or B, Azure ARM templates, or C, build everything manually? Now, who wants to make a choice here? Sounds good. The only other option on there I would recommend apart from PowerShell is to use Azure ARM templates, which is quite useful. Has anybody used Azure ARM templates before? They are really good. You can use them quite a lot in Visual Studio and Visual Studio Code. And basically, it's effectively just a JSON file where you can specify your entire infrastructure in Azure. And then all you have to do is run one line of PowerShell command stating that JSON file, and you can deploy your whole infrastructure as is. It's quite powerful, and as well as PowerShell, it might be worth looking into. So, you decide to use PowerShell to manage your virtual machines, and you want to ensure your costs are as low as possible to make sure your Azure credit does not run out. Now, as some of you probably know, I'll just quickly explain through this. If you have a Visual Studio subscription, you get assigned Azure credit every month. And you can think of Azure credit a bit like pocket money. Once your Azure credit has run out for that month, that's it. You can't use it again until the following month. So if you are testing in Azure using one of these subscriptions, just try and use a bit of sense of what you create in there and make sure you delete them as soon as possible afterwards. Anyway, back to the tell. And you start writing your script to deploy your virtual machines. And you want to make sure your virtual machines are added to the domain, and as well as having SQL Server installed as well. So how do you decide to do this? Do you A, use desired state configuration to complement your PowerShell that you've got in place? Or do you B, write a PowerShell script to deploy all the servers? Or do you C, deploy virtual machine images with SQL Server pre-installed? So, who wants to make a choice here? Anybody? So you're going for A, desired state configuration. Now going back to the options we just had back at there, you could have obviously used PowerShell to deploy your virtual machines individually and done the custom installations on each one. Also, you could have used the predefined machine images that come with Azure as well. However, the only issue with using those pre-installed images are that they might not be suitable for your work environment, so you may have to play with customizing them or change them to suit your own needs. So anyway, back to the tell. And you decide to use desired state configuration to do this. And there's a steep learning curve involved, but finally you get there and you have something you can reuse. Now there was one thing I should add here. Desired state configuration is quite good to handle this. However, going back to something we talked about earlier with the ARM templates, if you implement DSC within your ARM templates, it will stop them being what's called idempotent, which means you won't be able to reuse them as easily. So it's something to keep in mind if you use them. Anyway, back to the tell. And since you are testing things in Azure, you decide to look into using a platform as a service solution. So, one Friday afternoon, you decide to test a platform as a service solution based on SQL Server in Azure. So which one do you decide to look at? Now, before I get you all to vote on this, does everybody know the difference between IaaS and PaaS? Infrastructure as a service and platform as a service? Well, for the benefit of those of you who don't know, I'll just show you this quick diagram. Basically in Azure, the two main ones that people tend to use is infrastructure as a service or platform as a service. Infrastructure as a service effectively means you create your own virtual machines in Azure, and then you use SQL Server that's installed on those machines. Whereas platform as a service, as you can tell from the diagram there, means you literally just log into Azure and use that service straight away. So if you use platform as a service, there's no underlying operating system for you to support. Microsoft supports all of that in the back end. So hopefully that explanation's made it a bit clearer for some of you. Anyway, back to the tale. And like I say, which one do you decide to look at? A single Azure SQL database offering, or B, the Azure SQL database managed instances offering. Now, who wants to make a choice here? Nope, I tell a lie. There's two choices here. I knew I'd slip up somewhere. So, it's going to happen sometime. Put your hands up if you vote for A. And put your hands up if you vote for B. Again, B is very popular today. Definitely have to mix these up in future. Now, I just quickly cover some of the stuff in the single database offering before we look at managed instances. One or two of you may be wondering why there's not an option up here for Azure SQL Database Hyperscale. That's technically a part of the single database offering. For those of you who don't know what Hyperscale is, it's basically a cloud-ready version of SQL Server offered as a platform as a service solution. It's been slightly re-architected behind the scenes to deal with a high throughput of transactions. Anyway, back to the tale, and you unanimously voted for B. So, you go to install your first managed instance. And since it's initially for testing purposes, which tier do you decide to use? Do you decide to use A, general purpose, or B, business critical? Now, I'm not going to do it. Put your hands up if you vote for A. And put your hands up if you vote for B. Okay then, this time around, A is popular. I think some of you probably know why. So, you use the general purpose tier. It's exactly what you need at a reasonable cost. And you set everything to the lowest value because it's the first time you install it using your Visual Studio subscription. And whilst waiting for the deployment, you get called away for an urgent issue. And then you go home after you've sorted your urgent problem out and you accidentally forget that you've got this deployment running. However, luckily when you come back in on Monday morning, you just about have enough Azure credit left to carry on and to delete your managed instance. Now, if you'd gone for the business tier and you got called away on a Friday afternoon for an urgent issue and come back on a Monday morning, you would have found that all your Azure credit would have gone, and in fact your Azure account would have been disabled until the end of the month when your credit's renewed. So it's always a good idea, if you're going to create something new, I do recommend setting everything to the lowest value possible. Now, to set some realistic expectations about managed instances, has anybody deployed them before? And if you have, how long did they take? Okay, well, managed instances is not a fast thing to deploy, just due to the infrastructure in the background. I managed to get it just under 4 hours by setting everything at the lowest setting possible. I've heard some people say it takes on average about 6 hours for one to be deployed. And I've heard some people say that it's taken them 22 to 24 hours. So I just want to set you realistic expectations there when you go to deploy this. In fact, it's actually faster to deploy a big data cluster than it is a managed instance. So, your boss has asked you to join them in an architectural meeting to discuss upgrading a physical 2-node failover cluster instance environment. And what I mean by that is a traditional environment where you have two servers with all the storage shared on the SAN. So, you look at the proposal and the architect has done the standard practice, upgrading the hardware from a previous design, which includes a mid-range processor and all the storage on the SAN. So what's the first thing you'd like to discuss? Is it A, the possibility of having your temp DB files locally? Or is it B, would you be able to use always on instead of a failover cluster instance? Or is it C, what RAID level you'd want to use on the new SAN? Or D, why the processor specified isn't the top of the family for this particular socket set? Now, who wants to make a choice here? I'll let it all sink in a minute. So you're saying B, yeah? So would you be able to use always on instead? So you asked the possibility of using an always on availability group instead of a failover cluster. And they informed me that due to the cluster installation was decided due to legacy reasons. So just bear that in mind if you have any input into the designs if you go to work for a new company. Anyway, how do you respond to this? Do you say A, okay, that's understandable? Or do you say B, you can have a secondary server and an always on availability group for disaster recovery purposes? So, put your hands up if you vote for A, and put your hands up if you vote for B. I could see that coming. So yeah, just in case anybody isn't aware, it's the same in always on availability groups or anything else that requires a secondary database instance. You are allowed to have one as part of the DR strategy, as long as there's no workloads against it. So you explain this to your manager, and they say that's great, because it means that you can use it for backups as well to take the stress off the main server. How do you respond to their comment about this? And as you can see, there's only two options here, which are A, yes you can, or B, I'm afraid not. So, put your hands up if you vote for A, and put your hands up if you vote for B. Well, I have one lot of A today anyway. So you explain to your manager that's not the case because a backup is technically a workload. And then you proceed to explain to them that anything at all done against a secondary, including queries, backups and checkDB, are seen as a workload. So if you want to do that on your secondary, it will need to be licensed. Now I know some of you worked with SQL for some years and know this already, but you will be surprised how many people still do not realize this. I've gone into companies who are still doing all this stuff on their secondary instances thinking that they don't need a license. So, next you ask what level of storage for SQL the SAN will be using. And they tell you it would be RAID 6 with plenty of space, as the SAN will be dedicated for this environment, which I can tell you is a very rare thing these days when people are trying to save money. Usually your storage is shared with multiple teams. So anyway, because you've got this SAN all by yourself, what is your response to this? Is it A, RAID 6 will be fine, or B, we can go down to RAID 5, or C, can we use RAID 10 instead? Now, who wants to make a choice here? So you want to go for C, can we use RAID 10 instead? So, you ask if we can use RAID 10 and they ask you why, because it means you're going to end up using more disks. And you explain to them that since we're going to have this SAN all by yourself, RAID 10 would be better, because you only get a 2 times write performance penalty with it. Whereas if you keep it at RAID 6, you're going to get a 6 times write penalty. So you should use RAID 10 where possible, especially in this situation. So they amend the proposal, and you ask that once the environment is deployed, that it's tested using disk speed, which for those of you who don't know is Microsoft's replacement for SQL I/O. So is anybody here that's still using SQL I/O for testing? No? Is there anybody here who's using disk speed? Oh, good. So for those of you who don't know, SQL.io used to be used to test throughput, but these days everybody uses disk speed. So you asked why the process is specified and not the top of the family for this model. And they explain it's based on an order quote from the server manufacturer. And they can get another member of the socket family put in there for you. So which one do you want? Now, there's something I should explain here. You will find a lot of the times in the quotes that the hardware is actually a bit older than you think. And they give you these quotes and they give you these servers, and they actually usually quote in there an older processor for you. So it's something to keep an eye on if you do ever end up in this situation. However, of course, with things moving more to cloud-based, these situations are becoming a thing of the past. Very niche cases at the moment. Anyway, there's only two options here. The newest model in the family, or whichever one performs well with a similar number of cores. So, put your hands up if you vote for A. And put your hands up if you vote for B. And again, it's B. So, you ask for whichever processor performs well with a similar number of cores. And when they ask you why, you explain it's due to licensing costs. And you also explain to them as well that having the highest member of the family for a particular socket set doesn't necessarily mean it's the best for SQL Server performance. For those of you who don't know, if you come across this situation, it's worth doing your homework to check which CPU in that socket family works the best with SQL Server. There are quite a few sources online you can use to test this. Anyway, your boss looks very relieved that you saved them a lot of core-based licensing costs by choosing a mid-range processor. So that's the other thing as well. Obviously, if it's the newest member of the socket family, it's going to have the most number of cores. SQL Server uses core-based licensing, so you're going to end up paying a lot more money. Anyway, after the meeting, your boss catches up with you for a quick review. And they're pleased with how you've handled the SQL Server issues recently, including the CheckDB and the statistics problems, as well as your other efforts relating to the ever-changing data platform. And they're impressed by how keen you are to keep up new technologies and your level of expertise. And they see a bright future for you within the business. So, as you can imagine, everybody, that is the end of today's tale, but not quite the end of today's session. Now, I will be giving away after this session the slides for the beginning and the end of this session, but not the core tale itself, because simply there's just too many options to choose from for everybody. However, if you can't wait for the slides, you're more than welcome to take photos of these links now on the screen. And these ones are the links for SQL related scripts, which we may or may not have covered today. And looking at these, we didn't cover any of them at all because they're part of another situation in this session. But I do recommend looking into some of them. In addition to that, there's links for SQL Server 2019 content we covered today, including the Big Data Cluster workshop we talked about, and SQL Server documentation. It's worth as well, if you're interested in SQL Server 2019, looking at the SQL Server 2019 labs, as they give you practical hands-on experience with SQL Server 2019. Trust me, I've gone through it all myself and it is really good. Now here's links for other tools and documentation as well. As you can see up there, we actually only covered disk speed briefly today, but there are other things on there which you might want to look to use as well. If you're looking to migrate objects from one instance to another, and if you're not using DBA tools already, I highly recommend you do. And that is the end of the session. Now, normally I reserve time for questions, but there is literally 1 minute left. So the best thing to do is either contact me during the rest of the day, or contact me online using any of the social media platforms I showed earlier. So all that's left for me to say, everybody, is thank you very much for attending today's session, and I hope you enjoy the rest of today's event.